In this video, we will go over the Unit 2A study guide. As you can see, I filled in the chart for finding the vertex, the domain, and range of all three forms of a quadratic equation. To find the vertex in standard form, to find the x value, you use the formula x equals negative b over 2a. And in vertex form, x is equal to h. And in intercept form, x is equal to p plus q over 2. The domain for all three functions is all real numbers, which can be denoted with a hollow r symbol. And the range, when the parabola faces up, is y greater than or equal to k. And the range when the parabola faces down is y less than or equal to k. In number 1, it says graph the two parent functions and write their equation. Well, the two parent functions they're referring to are absolute value functions and quadratic functions. In an absolute value function, the parent function's vertex starts at the origin. And then it goes up 1 over 1, up 1 over 1, up 1 over 1, all the way forever and ever and ever. So we'll put an arrow at the end of that. And then the points reflect and go up 1 over 1, up 1 over 1 to the left as well, forever and ever and ever, giving us the V shape of the absolute value function. The equation of the absolute value function is y equals absolute value of x, and in function notation is f of x equals the absolute value of x. A quadratic function's vertex also starts at the origin, 0, 0, and then forms a pattern of up 1 over 1, up 3 over 1, up 5 over 1. If there was room, I could do that. And then reflects over the y-axis, giving us this shape here called a parabola. The equation for a parabola is y equals x squared, or in function notation, f of x equals x squared. In number 2, it says describe the transformation from the function f to g. F is the parent function of a quadratic equation, and g has a vertical shift or a vertical translation two units down. G is also wider than f, which is called a vertical compression. Number 3 says, let G be a vertical stretch by a factor of 4, a reflection over the x-axis, and a translation 2 units up of the graph of f of x equals x squared. So that's the parent function. It says write the function g. So we're going to use function notation g of x equals, we have a reflection over the x-axis. That tells me that my first symbol is negative. My first number is negative. And a stretch of a factor by a factor of 4, g of x equals negative 4. And then a translation of 2 units up of the graph of the parent function. So we're going to have, since it's up, we're going to have x squared, where the square is only on x. And then we add 2 to the end of this. That is our k value. G of x equals negative 4x squared plus 2. For number 4, it says, let G be a vertical shrink by a factor of 1/3, a translation 2 units up, and 4 units to the left of the graph of f of x equals x squared. Write g of x, or write the function g. So g of x is equal to, we have a vertical shrink, so that will be our first number, and it will be positive because we do not have a reflection. And then we have a translation up and to the left. So that means we're going to have to put a quantity in parentheses, and x plus 4, since it's going to the left, we use plus 4, and then we square that entire quantity. So it's very important that you put the square on the quantity and not the square on the x, because that 4 has to be included in the square. And then we have 2 units up, so we will add 2 to the end. Number 5 says, describe the transformation of g of x equals negative x plus 2 squared from the parent function. So I have this negative value here that is going to reflect over the x-axis. And then I have a 2. Notice it's inside the parentheses. It's part of the square. So that is going to be a translation 2 units to the left. Describe the transformation of g of x equals 5x squared minus 3 from the parent function. So this time we have this value out front, this 5. 5 is greater than 1. Therefore, this is a vertical stretch by a factor of 5. And then it has this value minus 3 after the square, which tells me that it is a translation 3 units down. Okay, we have that same diagram again here, indicating how to find the x value, the domain, and the range. And now we're going to especially use that information to graph quadratic equations in all 3 forms. It says graph the function using a table. Label the vertex and the axis of symmetry and tell if it has a maximum or a minimum. Give the domain and the range of the function. So we're going to start by identifying which form this quadratic equation is in. So this quadratic equation is in vertex form, which tells me I can find the vertex by just looking at the equation. So I need the value of h and k. H is positive 4 and k is positive 2. So the vertex is 4, 2. The axis of symmetry is x equals the x value of the vertex, which is 4. The domain is all real numbers for every quadratic equation. And the range is y greater than or equal to the y value of the vertex, which is 2. And I know that it is greater than because the a value is positive. Therefore, this parabola will be facing up, which makes the range greater than or equal to. Since this parabola faces up, that also gives me a minimum value. Okay, now I'm ready to graph the equation. And I'm going to use my vertex at 4, 2. So I have 1, 2, 3, 4, up 2. Here's my vertex. I'm going to plot or graph my axis of symmetry. That vertical line. Notice I use a dashed line indicating that it is not part of the solutions. And now I'm going to use the t-chart and I'm going to pick values to the right of the vertex. So I picked x equals 5, 6, and 7. Now I'm going to use the equation y equals 3 times 5 minus 4 squared plus 2. And I'm going to simplify that. Y equals 3 times 1 squared plus 2. So y equals 3 times 1 plus 2. So y equals 3 plus 2, y equals 5. So I have the point 5, 5. Which is right here. Now I plug in 6, which I can do by erasing the 5. And that will make things streamline a little bit easier. Okay, so I have 6, 3, y equals 3 times 6 minus 4 squared plus 2. 6 minus 4, that's 2. So y equals 3 times 2 squared plus 2. 2 squared is 4. So y equals 3 times 4 plus 2. And 3 times 4 is 12. And 12 plus 2 is 14. So this is the point 614, which I will not be able to graph on the graph. Okay, now that I have the right side done, I just simply reflect over the left side of the axis of symmetry, and I have this parabola right here. Number 8. F of x equals negative 1/3 x minus 4 times x plus 2. This equation is in intercept form. And an equation in intercept form, to find the x value of the vertex, I use the formula x equals p plus q over 2. Okay, don't forget when you use the formula, p and q are opposite of what you see. So for p, I will have positive 4, and for q, I will have negative 2. So 4 minus 2 over 2, the x value of the vertex is 2 over 2, which is 1. Now to find the y value of the vertex, I take 1 and I plug it into the equation. Y equals negative 1/3, 1 minus 4 times 1 plus 2. Y equals negative 1/3 times negative 3 times positive 3. Okay, negative 1/3 times negative 3 is positive 1, and positive 1 times 3 is 3. So y is equal to 3. So that is my vertex, 1, 3. That means the axis of symmetry is x equals 1. The domain is all real numbers. The range is y less than or equal to 3, because the leading coefficient here is negative 1/3. So because it's negative, that means it's going to face down. And since this faces down, that is going to give me a maximum value. Okay, so now I can plot my vertex at 1, 3. 1, 3 is here. I can graph the axis of symmetry here. And now I will pick points to the right of the axis of symmetry, 2, 3, 4, 5, and so on. And now I will plug in those values to find more points. Okay, so y equals negative 1/3, 2 minus 4 times 2 plus 2. Y equals negative 1/3 times negative 2 times 4. So negative 2 times 4 is negative 8, and negative 8 times negative 1/3 is y equals 8/3. So 8/3 is my y value. Now to graph that, I will go 1, 2, and then from here I'm going to count up by thirds. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when I count by thirds, you can see that I'm cutting each square in thirds. Okay, now I can plug in 3 So I get 3 minus 4 and 3 plus 2, which gives me -1 and 5. And -1 times 5 is -5. And then -5 times -1/3 is +5/3. Okay, so from the origin, I go 3, 1, 2, 3, and then up 5/3, 1, 2, 3, 4, 5. Okay, now I'm going to do 4. So I plug in 4. 4 minus 4 is 0. 4 plus 2 is 6. 0 times anything is 0. So the y value here is 0. So I have the point 40, which is right here. Okay, I can do more and more points because this graph is super wide, so it allows me to put more points on here. Okay, this time I'm going to plug in 5. So 5 minus 4 is 1, and 5 plus 2 is 7. So 1 times 7 is 1. I'm sorry, is 7. And then 7 times -1/3 is -7/3. So for 5, I've got -7/3. Okay, I can plot that point. 5, -7/3. I've got 1, 2, 3, 4, 5. And then -7/3. This time I'm counting 1, 2, 3, 4, 5, 6, 7. I'm counting down 7/3. Okay. Now I'm going to plug in 6. Going to have a really accurate parabola here. It's going to be very nice looking. Okay. Plug in 6. 6 here, 6 here. 6 minus 4, that's that's +2. And then 6 plus 2 is 8. That gives me 2 times 8 is 16, and 16 times -1/3 is -16/3. So -16/3. Okay, now to plot that point, I go over to 6, and then I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I think that's probably enough points to make an accurate representation of this parabola. So now that I have the right side completed, I can reflect over the axis of symmetry. So I put a dot here, and then I got 1, 2, 1, 2, and then I've got 1, 2, 3, 1, 2, 3, and then I've got 1, 2, 3, 4, 1, 2, 3, 4, put a dot there, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Nice little reflection. And as you can see, the more dots you have, the nicer your parabola will be. Okay. That's a good looking parabola. Okay, number 9. This equation is in standard form. So an equation in standard form, to find the vertex, we start by finding the x value using the formula -b over 2a. So my b value is the coefficient of x, that is 4. So x equals -4 over, my a value is the coefficient of x squared. So 2 times -2. So that gives me -4 over -4, which is 1. So the x value of my vertex is 1. Now to find the y value, I plug 1 into the equation. Y equals -2 times 1 squared plus 4 times 1. So y is equal to -2 times 1 plus 4, because 1 squared is 1, and 4 times 1 is 4. So y is equal to -2 plus 4, which gives me y is equal to 2. So my vertex is 1, 2. Okay, now I can state that the axis of symmetry is x equal to 1. The domain is all real numbers. The range is y less than or equal to sorry, y is less than or equal to 2, which is the y value of the vertex. And then because this parabola faces down, that means I will have a maximum value. Now I'm ready to plot my vertex. 1, 2 is here. And then I can graph my axis of symmetry using a dashed line. And now I will pick a few points to the right of the vertex. 2, 3, 4, 5. I think that's probably all I'll be able to do. So I will plug y equals -2, plug 2 in for x. So y is equal to -2 times 2 squared plus 4 times 2. Y equals -2 times 4 plus 8. Y equals -8 plus 8. Y equals 0. So when x is 2, y is 0. So I plot that point there. And now I can change 2 into 3. Y equals -2 times 3 squared plus 4 times 3. 3 squared is 9, so -2 times 9, and 4 times 3 is 12. -2 times 9 is -18 plus 12, which gives me -6. So 3, -6, which is right. Let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. And it looks like that's all I'm going to be able to do. 4 will put me way off the graph. So now I will just reflect 1, 1, 2. And I will have this parabola right here. Okay, moving on to the word problem. It says that a passenger on a stranded lifeboat shoots a distress flare into the air. The height in feet of the flare above the water is given by f of t equals -16t times t minus 8, where t is the time in seconds since the flare was shot. The passenger shoots a second flare whose path is modeled by the graph. Which flare travels higher? Which remains in the air longer? So what we need to do is we actually just need to find the vertex of the equation given to us, and then we'll compare that to the vertex in the graph. Okay, it's two different quadratic equations, so we're going to have different values, but we can use the vertex to tell us this information. Okay, so what we're going to do is I need to tell you that the t right here is in the place of what is normally an x, right? When we look at a quadratic equation and we see an x and we graph that, the graph is xy plane, right? But this is actually t for time, so they just use t, but it's the same as the x. It's going to act just the same. So in our graph, this value right here is t. And this value right here is F, which stands for the flare height. F stands for flare height, so F of T. So T in time and flare height. Okay, so we're going to find those values for the equation that they gave us, and we're going to compare them to that vertex right there. Okay, so first thing we need to do in order to find the vertex is you have to identify what form it's in. Okay, so this equation right here is in this one is in intercept form. So this intercept form equation has to use the formula for intercept form, which is P plus Q over 2. Okay. Now you might notice that this first T doesn't have a P value with it. It's not in parentheses with, well, that tells you right there that P is 0. Okay, and the Q value in there, remember it must be opposite. We're going to call Q 8. Okay, 0 plus 8 over 2 is equal to 4. So the X value of the vertex is 4. And now to find the Y value of the vertex, we will plug 4 into the equation. So f of 4 is equal to negative 16 times 4 minus 8. So f of 4 is equal to negative 16 times 4 times negative 4. So that's going to give us f of 4 is equal to negative 16 times 4 is negative 64. And negative 64 times negative 4 is positive 256. So the Y value of the vertex is 256. Now don't forget, we used X and Y, but this is actually T and that's actually F, time and flare height. So now we can use this to answer the questions. It says, which flare travels higher? Well, the height of the equation is 256 and the height of the graph is 196. So the first flare travels higher. Okay, first flare travels higher. Now, which one's in the air longer? Well, the vertex is actually only half of the time, right? As you notice, as this goes up, it goes up for 3.5 seconds, but then it comes down for 3.5 seconds, making a total of 7. Well, in our equation, it goes up 4 seconds. That means it's going to come down for 4 seconds, which means it's going to be in the air for 8 seconds. So the first flare is in the air longer. Okay, so that answers those two questions. Now we are going to write the equation of the parabola. Okay, so when you do this, remember there are two forms that you can write your equation in. So you have to be aware of that. Now the key to this is finding the value of A. So what I want to do first is I want to label my points because it's very important. So first thing I need to do is recognize that in number 11, they're asking us to find the find the equation that passes through that vertex. So if they gave us the vertex, then we need to use vertex form. So we're going to use vertex form for this one. Okay. And now since we're using vertex form, we have to think about what values are in the vertex form. So y equals a times x minus h squared plus k. So here's the beauty of this. They already gave us the value of x and the value of y and the value of h and the value of k. All we have to do is find a. So I'm going to plug those numbers into the equation. 12 equals a, the thing I'm trying to find, times 1 minus 10 quantity squared minus 4. And now I have an equation that I can solve for a. So I need to simplify the right side first. So I'm going to do 12 equals a times negative 9 squared minus 4. And now I'm going to be very, very careful because a is attached to negative 9 squared by multiplication. So that supersedes that minus 4. So I got to be really careful here. Negative 9 squared is 81. So what I'm going to do here is I'm going to write 81 as a coefficient of a. And that's going to alleviate any temptation to try to do 81 minus 4 because I can't do that. I'm not allowed to. I have to add 4 to both sides now. And I get 16 equals 81a. And then to get a by itself, I divide by 81 on both sides. And I get that a is equal to 16 over 81. Okay? And that does not reduce. So I'll just leave a like that. And now I'm ready to write my answer. Finding a gets you to the answer, but that's not the answer. The answer is the equation of the parabola. Okay? So again, I'm going to reference this here. y equals 16 over 81, quantity x minus 10 squared minus 4. Notice that x and y are letters now. I do not replace those with the numbers, because in order for it to be a parabola, we have to have infinitely many possibilities for x and y. We can't be limited to the x and y that they gave us. Okay, doing the same thing. We're going to write an equation, but this time we're going to write an equation in intercept form. Okay, so now I have to know what are the parts of intercept form. Y equals a times x minus p times x minus q. Okay, so again, I'm going to go up here and I'm going to label these parts. They gave me a value for x and y, and then they gave me p and q. Okay, so I'm going to plug those values in, and then I'm going to solve for a. So y is 3. 3 equals a times x is 4 minus, oh, it's going to be plus 1 because it's a negative 1 as an intercept, which means when it goes in the equation, it's plus 1. And then 4, again, because I have two x's, I got to put the value in both spots, and then minus 5. Now I have an equation that I can solve for a. So 3 is equal to a times 5 times negative 1. So again, these are attached to a by multiplication. So when I figure this out, I'm going to write it as the coefficient of a. 5 times negative 1 is negative 5, which makes negative 5a. Being very careful there. And then if I divide by negative 5, I get a is equal to negative 3/5. Okay, now I have a. I'm ready to write my answer. Y equals negative 3/5 times x plus 1, x minus 5. Again, x and y are letters in my final answer so that I can have infinitely many possibilities for x and y. That's what creates the parabola. Okay. Number 13 says, write an equation of the parabola that passes through 0, negative 18, and has x-intercepts of 9 and 1. So again, this one's intercept form. This is the value for x and y. This is p. Oops, I said p and wrote q. This is p and this is q. Okay, so now I'm going to plug those numbers in. Negative 18 equals a times 0 minus 9, 0 minus 1. And now I'm going to solve. Negative 18 equals a times negative 9 times negative 1. Again, multiply those together and put them as the coefficient of a. So negative 18 equals 9a. Now when I divide by 9, I get that a is equal to negative 2. And I write my equation, y equals negative 2 times x minus 9 times x minus 1. Okay, and the last one, I actually have a picture, and it looks like they gave me a dot for my x-intercepts, and then they gave me a third dot to use. I can use those, but honestly, I could also write this in vertex form because I know where the vertex is, so that's an option as well. Okay, I'm just going to go with what with the dots they gave me, and so this is P, this is Q, and then this will be my X and Y values. So it looks like P is equal to negative 2, and Q is equal to positive 6. Okay, and then my X and Y values are 0, 3. Okay, so I've got 3 equals A times X plus 2. No, not X. Why did I put X? Silly. 0. 0 is my X value. 0 plus 2. And then 0 minus 6. Okay, 3 is equal to a times 2 times negative 6. So 3 is equal to, when I multiply these together, that's negative 12a, and that's the coefficient of a. And now I divide by negative 12, and a is equal to 3 divided by negative 12 is negative 1/4. So a is negative 1/4. I'm ready to write my answer. Y equals negative 1/4 x plus 2 times x minus 6. And that is the study guide for concept 2A, sorry, for unit 2A.